have this 555 timer with adjustable potentiometer. We're going to make an oscillator. So this is an oscillator, power LED and then output LED. So first, we're going to connect that into 5 volts. So we have now this yellow LED, the output, and then we connected the other probe or the probe of the oscilloscope. That is the oscilloscope to know the frequency of the oscillator. This is a square wave oscillator from 555 timer, generated by 555 timer. So we created an oscillator square wave from 555 timer, and then we're going to adjust the frequency by adjusting the potentiometer. Adjusting the potentiometer by turning this potentiometer. We can adjust the frequency of the square wave. We need 38 kilohertz to produce the right oscillation for our project. 38 kilohertz. So while we are adjusting the potentiometer, we can monitor the adjustment through oscilloscope. As you can see here, we have 75.83 kilohertz. This is the frequency of oscillation or the square wave. We're going to adjust that using our tools into we need 38 kilohertz for our project. So let's adjust it. So we have now 38.40, 38.3 frequency. We can see that by using the XY coordinates. So this is 38 kilohertz, 38.2050. With a period of 27.7 microseconds. We have a frequency of, it seems, 36 only. But here we have 38. So this is the 38 kilohertz. We have now the schematic diagram of our adjustable oscillator using 555 timer. So we have the pin out. Okay, this is the power LED and the output LED, yellow, power LED, red. The 555 timer has an output, pin number 3, the output, in which we produce a a square wave type of oscillation or oscillator. So in here, pin number 4 and 8, the threshold, the reset and the power connected to the 5 volts. And then pin number 7, the threshold connected is this 2 resistor. So this one is the potentiometer. So we can able to adjust the potentiometer, depends on what frequency we are going to use, or we can adjust this potentiometer 100k with the capacitor 102. Then pin number 1 grounded, pin number 5, that is control voltage, no connection. Into our output, this we have the output LED, the color yellow. We cannot see the blinking or the flashing of the LED because we adjusted the potentiometer for about 38 kilohertz. So the oscillation or the oscillator is capable of oscillating from 1 to 0 or on off square wave with a frequency of 38 kilohertz, which we are going to use for our project. We're going to use for the project we're going to make. So we cannot see the blinking of the LED. It is almost impossible to see the blinking because the frequency is 38 kilohertz. So we can see the output LED yellow as if it is a steady light. We just turn on the LED, but its frequency is 38 kilohertz, and the square wave is generated into the output by connecting the oscilloscope to the output. So the function of the 555 timer is as a oscillator that can oscillate a signal, a square wave, or continues to change its state from 1 to 0 or on off, or continues to oscillate. And it functions how this 555 function as an oscillator by charging and discharging of the capacitor into the circuit. Charging and discharging capacitor causing to produce an oscillation of 38 kilohertz. 38 kilohertz to the output, pin number 3 of 555 timer. We are still using 38.5 kilohertz, and we have now this push button. We're using an infrared remote control transmitter, and this one is a receiver with the sensor, infrared receiver sensor, then output LED with separate power supply, power bank. When I press the button, it will turn on the output LED. We have now our new schematic diagram. Figure 2, infrared transmitter receiver schematic diagram. So this is the original, the oscillator. Now we have this infrared transmitter. So they are the same, and there is a correction for the capacitor used. This is a ceramics capacitor, the C1. So all the components are all the same. The only difference is the LED used into the output. So here we are using a yellow LED output, ordinary. Now we are using this infrared transmitter LED with push button to the ground. This is the this is the infrared LED. I'm using here in the infrared transmitter. So what happened here is it emits or it transmits a 38 kilohertz oscillation, square wave signal from the output and being received by the, what's this, receiver. If there's a transmitter, we have a receiver. This receiver is called B38538. This is a sensor or receiver. It transmits or it modulates at 38 kilohertz. So it modulates a signal 38 kilohertz to the air and then being received by the receiver B38538. Since what happened now to the circuit? This new circuit, we have the power LED. I think this is 3.3K, same. And then same with the transmitter, power LED. And then the output LED, yellow, the same output we used in the previous oscillator. So when we transmit due to the push button or using a push button, it will modulate a signal of 30 kilohertz. Modulate means to transmit the signal to the air and being received by the receiver. When the push button, when we use the push button, it will now transmit the signal by triggering this push button. And then what happened now to the output side of the sensor? Pin number 1 is the output, pin number 2 ground, pin number 3 is the supply. It will pull down or it will make this output pin, it will pull down or making this allow signal or 0 to the ground, pulling it down to the ground, which make this transistor to, this is a PNP type transistor BC557, to turn on, because the current now flows into the LED, then to the emitter, then to the base, then flowing to the sensor, because the pin now is in a lost state, causing the LED to turn on because now the current flows into the emitter to the collector. This is how the current behaves in a circuit. It will forward biasing this transistor and will turn on this LED. This is a PNP type. Current flows into the emitter, and then to the base, biasing, turning on this transistor, then to the ground, so the current flows in this direction to the sensor. So it means the signal is, we are outsourcing the signal, and then it will turn on this LED once we press the button or when we modulate at 38 kHz. So this is a wireless transmission, a remote control using a transmitter, receiver, or the remote built by using 5x5 timer and constructing this 38 kHz. So this sensor is only used for 38 kHz. So around 38 kHz. So we can now have this wireless or remote control